Good afternoon, students. In previous class, we have completed the basic concepts of organic chemistry, and today's class we are going to start our new chapter, that is hydrocarbons. But it is the continuation of like basics only. Hydrocarbons topic is also related to organic chemistry, which is contained by reactions, in which these reactions are helpful in your 12th class. Okay, first we will see what is meant by hydrocarbon and what about its classification. Okay, let us start our class, all of you. I hope everyone you are clear about last concept, that is basic concepts of chemistry. Even I sent animated videos related to inductive effect, hyperconjugation, all of these also. Okay, okay, ma'am. If you have furthermore any doubts, no problem. Anytime you can contact me. I will clarify your doubts. Okay. Now let us see what about our next chapter heading. Our next chapter heading is hydrocarbons. By seeing the name itself, we can understand these are the compounds which contain two elements, carbon and hydrogen. These compounds contain only two elements, those are carbon and hydrogen. Okay, now what is the definition of hydrocarbon? This is the compound or the compound which contains only carbon and hydrogen. The compounds which contain hydrogen and carbon are called hydrocarbons. The compounds which contain hydrogen and carbon are called hydrocarbons. Okay, in basic concepts of chemistry also we have seen different types of hydrocarbons, alkanes, alkenes, alkynes. If you have seen all these examples, they contain only hydrogen and carbon. The double bonds, triple bonds, it is not the matter. Here we are talking about elements. Okay, when we are going through elements, these compounds contain only two elements. Those are hydrogen and carbon. Okay, C2H6, ethane, contain carbon and hydrogen. Propane, like that, so many examples we have seen, homologous series, everything. Okay, ma'am? Then just starting of this chapter, they gave some introduction part, theory part, as well as already known concepts they gave to us. Okay, once I will go through that topics which are present initially. After that, we will enter into the main concept. Okay, ma'am. Before going to that one, hydrocarbons classification we have to see. Let us see that hydrocarbons classification. Hydrocarbons are classified into three types. Hydrocarbons are classified into three types. Those are saturated hydrocarbons, unsaturated hydrocarbons, aromatic hydrocarbons. Hydrocarbons are classified into how many types, ma? Three types. Those are saturated hydrocarbons, unsaturated hydrocarbons, and aromatic hydrocarbons. Okay, saturated hydrocarbons are alkanes, cycloalkanes. Saturated hydrocarbons are alkanes and cycloalkanes. We know already alkanes. What is meant by alkane? Okay, they will follow the general formula CnH2n plus 2. They contain only carbon-carbon single bonds. The compounds which contain only carbon-carbon single bonds are called alkanes. Is it okay, ma'am? Even cycloalkanes also contain carbon-carbon only single bonds. No double bonds will be present in cycloalkanes also, but a closed ring will be happened. First carbon or any other terminal carbon will be involved in closed bond, means the ring will be closed. These are cyclic compounds. These are open chain compounds. These are cyclic compounds. These are open chain compounds. Example C2H6, ethane, etc. Coming with cycloalkanes, cyclopropane, cyclobutane, like that. Okay. they should contain only single bonds, ma. Only single bonds. Those are cycloalkanes and cycloalkanes and alkanes. Okay, next, unsaturated hydrocarbons. Unsaturated hydrocarbons contain multiple bonds. Carbon-carbon double bond, at least one. At least one carbon-carbon double bond or at least one carbon-carbon triple bond must be there. Then those are called unsaturated hydrocarbons. Okay, so unsaturated hydrocarbons example, alkenes, alkynes. Unsaturated hydrocarbons example, alkenes, alkynes. Alkenes contain carbon-carbon double bond, at least one carbon-carbon double bond. Alkynes contain at least one carbon-carbon triple bond. It is not a restriction that all the carbon-carbon double bonds must be present in alkenes. All the carbon-carbon triple bonds must be present in alkynes. We have seen already examples. Okay, at least one double bond is there, then it is coming under alkene only. At least one triple bond is there, then it is coming under alkyne. Like that, cycloalkene, even cycloalkyne. These are generally discussed under unsaturated. Okay, whatever it is, whatever the thing I wrote on the board coming under unsaturated, at least they should contain one carbon-carbon double bond or carbon-carbon triple bond. Then that is coming under unsaturated hydrocarbons. Saturated hydrocarbons, they should contain only carbon-carbon single bonds. We should not see any sort of carbon-carbon multiple bonds in alkanes or cycloalkanes, whatever it is. Okay. This is saturated. Next, unsaturated hydrocarbons. Coming under aromatic hydrocarbons. Aromatic hydrocarbons are the typical type of hydrocarbons. Okay. Regarding this aromatic hydrocarbons, separate concept is there after completion of alkanes, alkenes and alkynes. We have separate heading aromatic hydrocarbons. There, which type of compounds are called aromatic hydrocarbons? Okay. To be an aromatic compound, what are the rules it should follow? Suppose a compound should be explained as an aromatic hydrocarbon, it should follow some rules or it should obey some rules. What are those rules to say that compound as an aromatic hydrocarbon? Okay, those rules. Okay, if they follow the rules, then that is called aromaticity and those compounds are called aromatic hydrocarbons. Like that, clearly under the heading aromatic hydrocarbons will study. Okay, for example, now classification is started now. For that I am telling that benzene is coming under aromatic hydrocarbon. Benzene formula C6H6. Benzene formula C6H6. Okay, it is coming under aromatic hydrocarbon. In this, any other element is there? No, only carbon and hydrogen. Formula is C6H6. It contains only carbon and hydrogen. No other element is present. So that's why it is hydrocarbon only. But it will follow some separate rules to say that it is an aromatic compound. Those rules, everything deeply we will study in separate concept under the heading aromatic hydrocarbons only. Okay, this is the rough explanation of classification of hydrocarbons. Hydrocarbons are classified into three types. Those are saturated hydrocarbons, unsaturated hydrocarbons and aromatic hydrocarbons. Okay, next. In our hydrocarbons chapter, classification we have seen. Are you clear by everyone? Okay, saturated, unsaturated, aromatic. Which type of compounds are called saturated, which type of compounds are called unsaturated, and which type of compounds are called aromatic. These aromatic hydrocarbons clearly will study under fourth category. First we will go through alkanes, after that alkenes, alkanes, and finally aromatic hydrocarbons. These four compounds will study under the heading hydrocarbons. Is it okay? Now, after completion of this, what we are going to study in this concept, hydrocarbons. Let us see that one. we have four categories under these hydrocarbons we are going to study in this chapter, no? Alkanes, alkenes, alkynes, finally aromatic hydrocarbons. Alkanes, alkenes, alkynes and aromatic hydrocarbons. All these categories, okay, we will keep first heading alkanes. Under alkanes, introduction, preparations, physical properties, chemical properties. See, all of you, if you keep citing alkanes, first we will start introduction part. Nomenclature, isomerism, like this different parts are there under introduction part. After that, preparations of alkanes. How alkanes will be prepared. Those are chemical reactions completely. Physical properties, density, solubility, like that different physical properties. What about the physical properties of alkanes? Next, chemical properties. How they will undergo reaction with others. Okay, chemical properties means chemical reactions. How they will undergo chemical reactions with others. These are the four categories we will study for every side heading. First we will keep alkanes. All the four categories we will study. Next, alkenes. All the four categories. Alkynes. Like that every compound, every side heading. Alkanes, alkenes, alkynes, aromatic hydrocarbons. We will study deeply, okay, in this hydrocarbons chapter. At once we are going to complete this chapter. These rules or these reactions will be repeated for your 12th class also. Okay, ma. In 12th class organic chemistry, we have functional groups. Already you have little bit idea about functional groups. Alcohol, aldehydes, ketones, like that we have little bit idea, because in basic concepts of organic chemistry, how to give the names of functional groups, compounds we have seen. Okay. In this 11th class, reactions of or complete information about alkanes, alkenes, alkynes and aromatic hydrocarbons we are going to see. Like that, these same categories we will see for functional groups in 12th class. Okay, alcohols, phenols and ethers, aldehydes, ketones and carboxylic acids, amines, nitrogen containing compounds, haloalkanes and haloarenes. Like that, four chapters. Under four chapters we will see everything: introduction, preparations, physical properties and chemical properties. Okay, at that time we want to remember all these things easily. To make that one easy, here if you understand this concept, okay, reaction wise, if you understand the concept and if you remember them, it will be easy for you in 12th class also. Okay, ma. That is about this hydrocarbons what we are going to study. Okay, now let us see our side heading. Next side heading, start with alkanes. Okay, and we can go through introduction part of alkanes. Okay, ma. Directly we are entering into alkanes. Okay, and introduction part. Let us see that one, all of you. I hope till now what is the thing it was explained, it was clear for you. Okay, ma. Let us see our next side heading, alkanes. You know already in basic concepts of organic chemistry we have seen general formula of alkanes CN H2n plus 2. General formula of alkanes, that is CnH2n plus 2. Okay, these alkanes contain carbon and hydrogen, already we have seen, in which these alkanes must contain only carbon-carbon single bonds. No other bonds will be present. Only carbon-carbon single bonds must be present. Okay, alkanes and cycloalkanes we told now, but we will study about alkanes only. Is it okay? How these will alkanes we are going to introduce after the preparations, physical properties and chemical properties. Starting compound of alkanes CH4, next compound C2H6, C3H8. Every two successive compounds are differentiated by the group CH2. That's why this series is called homologous series. Alkanes are coming under homologous series. Okay, now what is the introduction part which is already known to us, that was given in textbook? Let us see that one, all of you. As already mentioned, just I am reading one. Definitely, it is actually, this is totally known to us. That's why I opened the textbook and I am telling that whether the point is known to you or not. But if you read once, you will come to know that already this concept was completed. Means initially introduction part I am telling, not preparations. Ma introduction part already we have known. As already mentioned, alkanes are saturated open chain hydrocarbons containing carbon-carbon single bonds. Methane is the first member of this family. Methane is a gas found in coal mines and marshy places. If you replace one hydrogen atom of methane by carbon and join the required number of hydrogens to satisfy the tetravalence of the other carbon atom, what do you get? You will get next compound C2H6. You will get next compound C2H6. If you replace one hydrogen and if you replace one hydrogen in methane with CH3, you will get next compound CH3, C2H6. Okay. This hydrocarbon with molecular formula C2H6 is known as ethane. Thus, you can consider C2H6 as derived from CH4 by replacing one hydrogen atom by CH3 group. Go on constructing alkanes by doing this theoretical exercise, that is replacing hydrogen atom by CH3 group. The next molecules will be C3H8, C4H10, C5H12, like that you will keep on going on. Okay, how many compounds? C10, C11, C12, anything you can go through. Okay, these hydrocarbons are inert under normal conditions. Inert means they will not undergo reactions easily because already they contain only single bonds. Carbon single bond carbon or carbon single bond H. All are single bonds, sigma bonds. Sigma bonds are stronger when compared to pi bonds. The compounds which contain pi bonds, they will undergo reaction easily when compared to the compounds which do not contain pi bond. If pi bond is there, pi bond can be broken down easily. Is it correct or not? If pi bond is there, pi bond can be broken down easily. That's why it will undergo reaction easily. But in alkanes, no pi bonds are present. All are sigma bonds. All are sigma bonds means to break that bond, it requires more amount of energy. Automatically, they cannot undergo reaction easily. That is the thing. These hydrocarbons are inert under normal conditions. They do not react with acids, bases and other reagents. Hence, they were earlier known as paraffins. Other name for alkanes, that is paraffins. Another name for alkanes, that is paraffins. It is obtained from two Latin words, parum and affinity. Parum means less. Parum means less. Affinity means reactivity. Affinity towards others. That means reactivity towards others. It is very less for these alkanes. Okay. By using these two terms, Greek terms, parum and affinity, they gave this name paraffins for alkanes. Para means very less. Okay. In Greek it is called param. In English that is called very less. Affinity means reactivity. Now these are called paraffins. Latin param little. Affinis affinity. Can you think of the general formula for alkane family or homologous series? The general formula of alkanes is CnH2n plus 2. Already mentioned CnH2n plus 2. Starting compound CH4, structure is tetrahedral. They mention in your textbook tetrahedral shape for CH4. Okay, in alkanes tetrahedra are joined together in which CC and CH bond lengths are 154 picometers and 112 picometers respectively. Carbon-carbon bond length is 154 picometers and CH bond length is 112 picometers respectively. You have already read that CC and CH sigma bonds are formed by head-on-head overlaps of sp3 hybrid orbitals of carbon and 1s orbitals of hydrogen atoms. In what way the carbon and hydrogen bond is formed in alkanes already we have seen. Carbon-carbon bond is formed. Carbon-carbon bond is formed by the overlapping of sp3 hybrid orbital of carbon and sp3 hybrid orbital of another carbon. Carbon single bond hydrogen is formed by overlapping of sp3 hybrid orbital of carbon and s orbital of hydrogen. Already we have seen in the structures of ethane, like that we have seen the structure of ethane, even in methane also we have seen. Okay ma? That complete head-on-head overlapping is called complete overlapping and it will be resulted as formation of sigma bond. These are all things we have seen in chemical bond also. Okay, that one only they give. In alkanes, you have already read that carbon-carbon and carbon-hydrogen sigma bonds are formed by head-on overlapping of sp3 hybrid orbitals of carbon and 1s orbitals of hydrogen atoms. Is it okay, ma? Next, nomenclature and isomerism. Under this introduction part only, next thing is nomenclature and isomerism. What is that nomenclature? IUPAC nomenclature only. We have known already how to give that IUPAC nomenclature. Even branched chain compounds also, so much complicated compounds also we give. Okay, that only they give again. See, you have already read about nomenclature of different classes of organic compounds in Unit 12. Nomenclature and isomerism in alkanes can further be understood with the help of a few more examples. Common names are given in parentheses. First three alkanes, methane, ethane and propane have only one structure, but higher alkanes can have more than one structure. Those are on isomers now. If number of carbon atoms are increased, we can make so many structures with same molecular formula. That only in isomerism we have seen. Compounds with same molecular formula but differed in their structures. Here chain structures, that is called chain isomerism. The property is called chain isomerism and those compounds are called chain isomers. Like that with same molecular formula we can draw so many structures. When number of carbon atoms are increased, those possibilities are also increased. Okay. But higher alkanes can have more than one structure. Let us write structures for C4H10. 4 carbon atoms of C4H10 can be joined either in a continuous chain or with a branched chain in the following ways. Okay, they have tried to draw the structures which are possible with C4H10. Now we will see on board. See all of you. C4H10. How many carbons must be there? 4 carbons. 1, 2, 3, 4. Hydrogens. Remaining are hydrogens. CH3, CH2, CH2, CH3. Straight chain. Molecular formula C4H10. Straight chain. Chain is straight chain. Okay. Next. Same molecular formula we can write in another way also. That is CH3, CH3, CH3. Name of this compound butane. This is 2-methyl propane. These two compounds have same molecular formula. If you want to try any other possibility with same molecular formula, you can try, but you will not get other compound because only two possibilities are there. If you want to try any other thing, it will be repeated with any one of the structures. Is it okay? If you want, try that one. After writing the structure, write the name also. Then that name and this name or any one of these will be repeated. So maximum number of possibilities we can draw chain isomers with butane will be 2 only. Names butane and 2-methyl propane. Common names N-butane. Common names N-butane. Second carbon has methyl group isobutane. Name of this compound, common name, this is an N-butane, this is isobutane. Because second carbon has CH3 na? If second carbon has methyl group, that is called iso. If second carbon has two methyl groups, that is called neo. Like that in one class I explained. Okay, these are the two possibilities with C4H10 molecular formula. They give the same structures. No? Now butane, boiling point 273 Kelvin. 2-methyl propane, isobutane, boiling point 261 Kelvin. You will be clear with these boiling points also slowly in physical properties we will study. Now we will go with the next possibility, pentane. With pentane, how many structures we can write in chain isomerism? Okay, that one we are going to see now. Let us see that pentane now. Pentane molecular formula is C5H12. First possibility, straight chain CH3, CH2, 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 CH3. This is pentane. Second possibility, CH3, CH, CH3, CH2, CH3. 2-methyl butane. What is the name of the second compound? 2-methyl butane. And third compound, CH3, C, CH3, CH3, CH3. This is 2,2 dimethyl propane. 2,2 dimethyl propane. Once I am repeating, first compound name pentane, second compound 2-methyl butane, third compound 2,2 dimethyl pentane, propane, 2,2 dimethyl propane. These are the three possibilities with molecular formula C5H12. If you want to try any other structure, you can try, but you will get definitely the name among these three. Okay, ma? Common names. This is N-pentane. This is isopentane because second carbon has CH3 group, isopentane. This is neopentane. Second carbon has two methyl groups, that is called neopentane. N-pentane, isopentane, neopentane. IUPAC names are pentane, 2-methyl butane, 2,2 dimethyl propane. Okay, ma? These are the structural isomers which are possible with pentane. They gave the names pentane, N-pentane, boiling point 309 Kelvin, 2-methyl butane, isopentane, boiling point 301 Kelvin, 2,2 dimethyl propane, neopentane, boiling point 282.5 Kelvin. Like this they gave. Once if you want, you can open the book and same thing they gave. The possibilities which we have known, we have written now. If you want to try any other new possibility with same molecular formula, you can try. But the important thing is, after writing the structure, you have to observe first main property is carbon must be satisfied with valency 4, hydrogen must be satisfied with valency 1. After that, try to give the name of that compound. Definitely that name of the compound will be repeated with any one of these three names, meaning no other possibility more than these three. More than these three, no other possibility with C5H12. But when number of carbon atoms are increased, that possibility is also increased. See, butane, 4 carbon atoms are there. We are able to draw 2 structures only. In pentane, 5 carbons are there. We are able to draw 3 structures. Like that, when number of carbon atoms are increased, okay, possibility of writing the structures also increase. If you want, try with hexane. Hexane, number of possibilities furthermore increases. Okay, ma'am. So your homework is try to draw the chain isomers like this. Possibility of chain isomers with the molecular formula C6H14. With C6H14, how many structures are possible? You can try it on your own. If you try it on your own, you will think that how can we draw the structures? Okay, what are the different possibilities? Everything you will think. Simply if you copy, like that only it will be. Okay, please try it on your own. After that, you can refer the notes. Or if you ask me, I will give the possible structures with hexane, C6H14, not hexane with molecular formula C6H14. Okay, next. Structures 1 and 2 possess same molecular formula but different their boiling points and other properties. See, two structures for butane, they have same molecular formula but boiling points are different or not. Two different compounds those are, but containing same molecular formula. That property is called isomerism and those compounds are called isomers. Okay, like that in pentane also, these are differed by boiling points. This is boiling point 309 Kelvin. This compound is contained by boiling point 301 Kelvin. This is contained by boiling point 282.5 Kelvin. You can remember when branches are increased. Here this is tight chain. Here one branched chain is one side chain is there. Here two side chains are there. Like that, when side chains are increased, boiling point decreases. 309, 301, 282.5. Straight chain molecules contain higher boiling points. Like this, branched chains compounds contain lower boiling points. That also, when branches are increased, the boiling points furthermore decreases. Observe here itself. This boiling point 309 Kelvin, this boiling point 301 Kelvin, this boiling point 282.5 Kelvin. Like that decreases. When side chains are getting increased, automatically boiling points increases. Decreases. Once again, boiling points decreases. Since difference in properties is due to difference in their structures, they are known as structural isomers. It is also clear that structures 1 and 3 have continuous chain of carbon atoms, but structures 2, 4 and 5 have a branched chain. Such structural isomers which differ in chain of carbon atoms are known as chain isomers. These are coming under example chain isomers. When they have same molecular formula but differed in the chains, structure of chains, that is called chain isomerism, and those compounds are called chain isomers. Okay, these are all called chain isomers. No? See, next compound they gave the problem 13.1. Write structures of different chain isomers of alkanes corresponding to the molecular formula C6H14. That only I give the homework. C6H14. With that, also write their IUPAC names. First try to write the structures. After that, write their IUPAC names. How many possibilities you will get? Check with problem 13.1 answer. But please don't see and write. Problem is given. 13.1 was given. In that, answer is also there. But please don't see that one. Try to write on your own. After that, check with 13.1. Here no one is there to examine you. Okay, you are the own examiner. Whether you are able to write that one, that is important here. By seeing, even though if you write 100 structures, it is not a matter for me. But without seeing, at least if you write 2 or 3 structures correctly, it is good. Really, I will appreciate that one. Please remember and try it on your own. Based on the number of carbon atoms attached to a carbon atom, the carbon atom is termed as primary. Like that classification is there, primary, secondary and tertiary. Okay, let us see. This compound contains primary, this is secondary, primary. If a carbon atom is bonded to one carbon atom only, that is called primary. If a carbon atom is bonded to two carbon atoms, that is called secondary. If a carbon atom is bonded to three carbon atoms, that is called tertiary. Like that we have seen in basics of organic chemistry itself. Okay, now like this here, this carbon primary, it is bonded to only one carbon. This carbon is bonded to three carbons, 1, 2, 3, tertiary. This carbon is bonded to one carbon, primary. This carbon is bonded to two carbons. Like that we can say primary, secondary, tertiary and quaternary. We know already. Okay, ma'am. After that they gave the continuation, and problem 13.2. Nomenclature of a few organic compounds. They gave right side yellow tabular column. Okay, once see this pink color one, problem 13.2. The problem 13.2 just once go through. Clearly tomorrow you can do. If you feel any burden to do that C6H14, today you can complete that C6H14. Tomorrow you can go through this one. The students who are interested to do today itself, you can go through once this one. What are the names they gave? Everything it was clearly explained. Whether you are able to understand or not, check that one. Okay, ma? Suppose corresponding alcohol they give CH3, CH2, 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 CH2OH. The name is pentan 1-ol. Like that, name of the alcohols they give with alkyl groups. Okay, try to understand, ma? Definitely you will understand easily because these are all simple compounds only. Okay, yellow colored one also once you can see. After that they gave problem 13.3. Problem 13.3 I will explain in next class. Remaining problems we will see later, ma'am. After that our next concept is introduction part is completed. UPSC nomenclature and isomerism. Okay, examples were given. Our next side heading is preparations of alkanes. Our next side heading is preparations of alkanes. We'll start with that one. Okay, till that whatever the thing we have in textbook, okay, once if you want you can refer, no problem. But the students who understood, yesterday I have gone through our Zoom online session also. They told that maximum number of students, they told that we understood the concept, sir. Okay, if you understand the concept clearly, definitely you can go through these problems easily. It is not a matter for you. Is it okay, ma'am? Now we will start our next reading, that is preparations of alkanes. Correctly, if you follow whatever I am telling, easy reactions only. From here onwards, reactions are started. Okay, slowly every concept I will teach, slowly only. Please try to understand everyone. Okay, preparations. First one, how alkanes are prepared. That is our concept, preparations. Under first one, from alkenes. From alkenes, we are going to prepare alkanes. From alkenes, we are going to prepare alkanes. How we are going to do that one? See, let us consider any one alkene. CH2 double bond CH2, ethene, will undergo reaction with hydrogen gas adsorbed on platinum, palladium or nickel. Any one metal we can take. This explanation I will give. What is this hydrogen gas slash platinum palladium nickel? That explanation I will give. Okay, this is the reagent. Hydrogen gas present on platinum palladium or nickel. This is the reagent. What is the substance it will undergo reaction? Ethene. Okay, ethene contains pi bond. Observe, between carbon and carbon one pi bond is there. That pi bond can be broken down easily. The pi bond can be broken down easily, and two hydrogens are there now here, in which one hydrogen atom is added to this carbon, one hydrogen atom is added to this carbon. Then we will get CH3 single bond CH3. Ethane. Simple, very simple. Two bonds are there here. One bond will be broken. One bond will be broken, which is pi bond. Out of pi bond and sigma bond, pi bond is weak bond. We know that pi bond can be broken down easily. Okay, the pi bond will be broken down. When the pi bond is broken down, this carbon has 3 valency, this carbon also has 3 valency. Then how it is fulfilled? Out of two hydrogen atoms, one hydrogen atom is bonded to this carbon, one hydrogen atom is bonded to this carbon to form ethane, which is called addition reaction. Simply hydrogen and ethene will undergo addition to form ethane. Okay, this is first preparation. Some more information about this preparation I will go through in next class. Before that, today we have seen, starting with hydrocarbons, how hydrocarbons are classified. Okay, and after that we have seen alkanes with introduction part, and we have started today one preparation also. That preparation is from alkenes. We have taken one alkene, undergoes reaction with hydrogen, platinum, palladium or nickel to form ethane. We have prepared ethane or not? We got the ethane. Okay, how we got ethane? When ethene reacts with hydrogen gas present on or adsorbed on platinum, palladium or nickel, we will get ethane as the product. Okay, importance of this hydrogen such that platinum, palladium or nickel, as well as, once again I will repeat this reaction in next class. Okay, note down these reactions carefully, all of you, in an order. Okay, that is about today's class. In today's class, what are the things I have taught for you? I hope you understood everything. Okay, that is about today's class. Thank you all. Have a nice day.